Hello guys, today go over an eye test problem, which is also example 2.4 in my special functions in the Amy handout. So for real numbers x, let the floor of x be the greatest integer less than or equal to x, and the fractional part of x equal x minus the floor of x. And so let s be the sum of all real numbers x such that 1's less than or equal to x is less than or equal to 100, and the fractional part of x squared is equal to the fractional part of x then squared. So compute the floor of s. And so first of all, we want to simplify this expression, and so we know that x is equal to the floor of x plus the fractional part of x. And so basically plugging this into the formula, we square it, so we get the fractional part of the floor of x squared plus 2 the floor of x, the fractional part of x, plus the fractional part of x squared. And this is equal to the fractional part of x squared. One thing that we can simplify this is that since the floor of x is an integer and integer squared is always an integer, obviously the fractional part of an integer is going to be 0, and so we can just cancel that part out. And so now in order for this equation to be true, we need that 2 times the floor of x times the fractional part of x to be an integer. Let's say that integer is b. And so let's say the floor of x is a. So that means that the fractional part of x is going to be equal to b over 2a. So that means that x itself is going to be equal to a plus b over 2a, and so that means that the values of x can range from 1 plus 1/2, 2 plus 2, 2 plus 1/4, 2 plus 2/4, etc., all the way to 99 plus 197 or 198, and then plus 100. Let's exclude the 100 for now, and we want to figure out how to sum this. So let's say for an arbitrary n, this is what the sequence is. So n plus 1 over 2n, n plus 2 over 2n, n plus 2n minus 1 over 2n. So we want to figure out how to sum this, and so there are actually 2n's, which are 1, 2, 3. There's 2n of these. And then we can do an arithmetic series, which is just 2. We can just do sum of terms, 2n. And so this actually gets us 2n squared plus n minus 1/2. And so we want to find the summation of this for all n. Let's make a summation. And so first of all, let's take the negative 1/2 out. So this is no longer in the summation, as it is a constant. And then now let's handle these separately. So what is the summation of 2n squared? That is just 2 times the summation of n squared. And there's a formula for the sum of n squareds. And so sum of 1 squared plus 2 squared plus all the way to 99 squared. This is just n times n plus 1 times 2n plus 1 all over 6. And so I'm just going to use a calculator here. What we get is 99 times 100 times 199 divided by 3, because we also have to multiply by 2. And so this gives us 656,700. 656,700. And I believe the calculator is allowed on this test, so this is actually the intended solution. And then lastly, we want to find the sum of n, which is just going to be 99 times 50, or I don't even need a calculator for that, 4950. And so finally, our sum is going for 950. We also have to add that 100 we forgot, and we have to subtract 1/2 at the end. So actually, we can just subtract by 1, as we are going to, I'll just do that after. So then 71666,170. So our answer is 661,749, as we have to subtract by 1/2 and find the floor. So thank you guys for watching. If you enjoyed this video, make sure to like and subscribe. This is the end of the video, and I'll see you guys in another one. Peace.